All right. Hey, everybody. I'm Sarah Khalife.
And I'm Griffiths.
And we'll be talking to you today about KinD-ly validating your Kubernetes apps automatically per PR. To give you a little background about myself, I'm a field solutions engineer. I've been at GitHub for 11 months now. Previously, I was a cloud apps and platform engineer at GE, where I worked on microservices, Kubernetes, and Cloud Foundry. Today, I'm focusing on inner source automation and improving the software development lifecycle. For fun, I enjoy volleyball, traveling, and the beach.
And I'm Grant. I've been at Portworx for about 1.5 years now. I'm a software engineer. Previously, I was at GE working on the data services team and platform engineer. I'm a contributor to SIG storage and Kubernetes CSI. And for fun, I like climbing, soccer, and surfing.
Awesome. All right, let's jump into our agenda. So today we'll give you a quick overview, what our motivations are, what our challenges are. We'll go into why KinD, jump into our automation and continuous integration conversations, give you a quick overview of what we'll be testing. We'll do a live demo right after that, and then talk about our takeaways. So let's start off with our overview. So why did we want to do this talk? Well, we wanted to be able to collaborate successfully in both internal and open source projects. We had some challenges. What were those challenges? Well, collaborating needs to be transparent, consistent, and rigorous. Testing Kubernetes applications varies all the time between per developer environment. It can vary against the different configurations that you have set up for your environment. And it's time and resource consuming to constantly spin up Kubernetes applications and Kubernetes clusters every single time you make a single change.
So yeah, what we'll cover is basically a simple set of steps to create and automate a homogeneous testing environment. And we'll use KinD to automatically run E2E tests across a common environment. And then we'll also automate the creation of this environment per pull request and run the test suite before merging. And you might notice a lot of fun pictures from Amsterdam. As you know, this conference was supposed to be in Amsterdam, so try to keep the theme going strong. So yeah, we're going to talk about KinD now. So KinD is basically Kubernetes and Docker. It's similar in usage to something like MiniCube or K3S, basically a different distro of K3S, of Kubernetes. It's great for local testing or testing even remotely in CI/CD. And if you want to learn more, you can go to kind.sigs.k8s.io. Yeah, all you need is Docker, and you can spin up your own Kubernetes cluster. So yeah, how do you actually do this? So if you're on a Mac or if you have brew installed, all you need to do is to brew install KinD and then KinD create cluster. So it's extremely easy to get started, probably the lowest barrier of entry tool to kind of spin up your own container scheduler ever. It's very awesome and a really cool tool to use. So this is kind of what it looks like when you start up. So it pulls the Kubernetes version, it prepares the nodes, and then it starts up all the different components. So just a quick comparison, you might be using another tool out there, maybe K3S or MiniCube. So I pulled up a quick comparison chart from this blog post we found. And basically it compares all the different miniature versions of Kubernetes pretty much. So for example, there's MiniCube that actually requires a VM, but it's a single node Kubernetes itself. They didn't change any of the Kubernetes code. That's the main difference between K3S and MiniCube. K3S is actually a slimmed down version of Kubernetes. They actually pulled out things like the volume drivers. You can only use CSI. And they pulled out some other things that are deprecated to basically lower the binary size so that it's very quick and a minimal version of Kubernetes. And KinD, as we mentioned, it's quick, easy to deploy, low barrier to entry, and great for testing.
So let's jump into our automation and our continuous integration. Today we have a couple of goals that we wanted to achieve when we ran our tests. So the first goal is to run our validation tests on new code changes. That helps us reduce the amount of bugs and validate before it hits production. We want to block merge to production if tests have failed. So if the test has failed, you don't want to merge any broken code. No introduction of broken code into your main branch or production branch. And you also want to hold the dev accountable to fix the issue. You also want to set up a pre-configured environment when testing. This allows you to systematically catch problems with your application logic, and it helps you maintain consistency across the results that you receive from your tests. Automate everything with event triggers. That increases the frequency of your test runs, that makes it more repeatable and generally more efficient. You don't want to spin up a test if it's just a simple code fix on a README, but you want to spin up a test when it's a pull request against your production code. All of that is great, but what's also top of mind, even from an individual developer point of view or from a enterprise point of view, or from an organization point of view, is it is the cost efficiency of using up resources. And you don't want to reinvent the wheel if somebody has already worked on something similar. So what do you think about when you do that? Open source. Open source comes into my mind all the time, especially because 90% of today's software is composed of open source software. You're using dependencies, you're using scripts that other people have worked on. So with that in mind, what did we do next? Well, we found an open source action that spins up KinD in Docker for us. KinD in Kubernetes and Docker for us. So with that, we were able to find a pre-existing action. I didn't have to reinvent the wheel. It's open source, so I was able to go through the code, make sure that it works for our use case, and we made sure that it's configurable so we can actually implement our own YAML files, make sure that we're using the Kubernetes version that we want to. So here's a quick link if you wanted to find the action that we used. Again, it's open source and you can find it on the GitHub Marketplace. So for our automation today, we'll walk through some of the components that we'll be talking in our demo. So we have our KittyCat dev over here. He introduces new code and creates a pull request. This pull request then triggers our automation workflow. That automation workflow spins up a build job and a publish job. So we build and publish it to DTR. After that, we spin up our KinD creation, our KinD cluster creation, our Kubernetes testing. That's great, but I also said that the KinD action was configurable so I can test against a Kubernetes version. Well, we use a matrix build to actually test against 3 different Kubernetes versions because I want my application to be able to run across all of these and be compatible. Once we have all of the tests passing and we're confident that this is not going to break any of our production code, that's when we decide to merge. We actually block the merge by implementing protected branches so we don't have to merge, so nobody will be merging code if the tests fail. And speaking of testing, let's jump into what we'll be showing in testing today.
Awesome. So yeah, now that we've covered basically at a high level what's going to happen, let's go into detail about testing and how you can actually test your Kubernetes applications. So typically you'd want to do this with integration or E2E tests. If you're going through the hoops of spinning up a Kubernetes cluster or a KinD cluster, you'd want to use integration or E2E tests. And the reason for this is if you have maybe dependency between apps, if you have like a database like MySQL or Cassandra or Kafka or something, and you want to basically see how your code interacts with those applications, or if you want to see how your code interacts with a Kubernetes object. Say your application actually needs to read from a secret or read from a config map or something, then you might want to actually do an E2E or integration test. But there are some reasons as to why you might not want to actually use integration tests. It can be very resource and time intensive, or basically unit tests can cover a lot of business logic. You don't need to spend 3 or 4 hours running all of your unit tests against an actual Kubernetes cluster, because that would be way too time consuming and not very smart use of infrastructure. So an example of out there you can actually see for yourself is being used in production is the Kubernetes CSI team has something called CSI release tools, just a repo that has all the release tools basically that we use to basically test all the different repositories for Kubernetes CSI. And inside of there, there's something called prow.sh. And what it does is it creates a KinD cluster, deploys a sample CSI driver and its sidecars. So basically its dependencies. And then it runs some tests against them. So basically it's an example the Kubernetes team itself actually uses to do development. And what we did actually for our example today is we did something similar. We basically started a Portworx E2E Test. And I work at Portworx, so it's a project that I work on, and is something called Portworx Security. Basically prevents unauthenticated users from accessing the platform. So you basically can't create a volume or mount a volume if you don't have the correct token secret. So that's kind of the test we're going to be going over, and we'll be testing using the Portworx CSI driver, which basically is a driver that allows you to create storage volumes. So yeah, and OpenStorage, just so we're clear, is the open source control plane for Portworx. So it's basically all of the code that basically handles like all the different control plane components. It doesn't have the actual storage layer. So yeah, let's go into our E2E test. So basically the first step you'll see, and actually when we talk about the demo, this is the same scenario that we're going to demo. So basically the first step is to create a KinD cluster. And inside of that KinD cluster, we're going to have a kube system space and then a user space as well. And then what we're going to do is deploy the Portworx CSI driver. That's going to be in the kube system space, and all of its dependencies will be there as well. Next, we're going to create a token secret. This is basically your password, and it's basically the token that's required in order to authenticate with Portworx. Next, we're going to create a storage class, and the storage class refers to our Portworx CSI driver. After that, you're going to create a persistent volume that basically looks at that storage class to get its parameters, and basically you'll create the persistent volume based on the storage class parameters. Next, we're going to create a pod that uses this, for example, a MySQL pod, and we're going to use the persistent volume to store its data. So the test scenario we have today is basically the test that we want to cover, and it's very crucial to the actual performance of PX security, is that you shouldn't be able to create a volume in a private system if you do not have a token secret. So in this case, actually right here, you'll notice that the test has failed, and that's because there's no link between the storage class and the token secret. So in order to get this test to pass, what we're going to have to do is create a link from the storage class pointing to the token secret to basically tell it to look for the token secret, so that Portworx knows where to find the credentials. And then the test should pass once we actually edit the storage class to look at that token secret. And that's actually what we're going to demo right now. So what we have is where we're going to do a screen share, and I'm going to show you all a pull request we have open already. So what we have here, as you may have noticed, this is OpenStorage. So it's basically the control plane components. It has the CSI driver and everything inside of it. So what we're going to do is we're basically going to open a little PR. Inside of this PR, we're just going to change really quickly and basically change from debugf to info-ref. Not the biggest change in the world, but for a demo, it's nice. And then what we're going to actually do is we're going to notice that the test is failing because I've manually set the token secret to be invalid. So what happens actually as a result is that the tests here are failing, as you can see. So it's preventing merging from happening because we have protected branch, which Sarah's going to talk about in a little bit. So basically what we do is we can bring up this test and we can look inside and we can see, oh, what happened? So run test failed. So let's go inside of run test, and we can actually see that it created the secret, created the storage class, it created the PVC. However, the PVC was not bound after 15 seconds. So basically, Portworx wasn't able to create the volume, and it said, who is this person trying to create a volume, because you don't have the correct token. So I'm not going to let you create a volume. So that's the reason for the test failing. So let's go ahead and actually fix that live right now. So what we're going to do is inside of here, we can actually just edit this. So if we edit the file, we can actually just change this real quick to be a valid token secret. Boom. So now what we're going to do is just commit that change. And now we just have our one change right here. So the test should pass now. So as you can see, since we set up our action to basically run on pull request open, when you update or you send a new commit, it'll basically rerun the tests and see if they pass or not.
Awesome. And then let's jump into a quick overview of what that will look like. It just kicked off our build test here, and we can see that it's building and running our Docker image build. So now that we are seeing this in action, let's jump into the actual YAML so we can talk through that. Here we have our E2E with KinD YAML file. This is our automated workflow. As Grant mentioned, we're only running this on pull request and specifically on pull request to master. The reason is around this is we don't want to run our end-to-end testing every time there's a push or a small change. We actually want to run it only on pull request because that will be the time where new code is being introduced into a master branch. In this case, we're using our master branch as our production branch, so we don't want to merge any code that hasn't passed the end-to-end testing in the first place. So now that we have our trigger here, let's jump into our different jobs. So our jobs here, we have two main jobs, our build and our test job. In reality, what we have learned trying to achieve this overall workflow is that we originally had our build and test job only in a single job. So it did build and test all at once. Why that really did not work is because the testing and the build jobs had two functionalities. The reason for the build job was to make Docker build OSD, and that ultimately builds our image and then pushes it to Quay. In our second job, we actually have our full-blown integration testing running with KinD, spinning up the cluster and running our test scripts. We split these up in the first place because our KIND's cluster creation and our tests are going to be run against 3 different Kubernetes versions. But when we build our image, we only need to build it on a single version. So we're running Ubuntu latest for both of these, but we did not need to spin up a different Kubernetes version to run our build job. But let's jump into our test job so you can see what we mean. So we have our test job. We said that our test job needs our build job because our build job runs and validates our content and then pushes the image to a DTR, Docker Trusted Registry, to Quay or to GitHub packages, wherever you want to store it. But in this case, the test job needs the build job. And similarly to above, we're running in Ubuntu. In this case, we have configured a matrix build. This allows us to concurrently run 3 different versions of Kubernetes. And this is simply an environment variable that kicks off 3 concurrent jobs. We use this environment variable later on when we're setting up our KIND cluster. As you see here, this is similar to what we showed in the PowerPoint, but this has the configuration that I mentioned. We're using this open source action and configuring it with our specific use cases. So we named our cluster name, we had our cluster name, we set up our own YAML, and we are testing against the different Kubernetes versions using the matrix build. With that matrix build in mind, we then set it up correctly to spin up all of our applications, and then we have our test being run in this case here. So now that we've seen all of that, let's go into a quick overview of what the branch protections rules look like. So here we have our master branch. This is the name pattern that you can decide on how you want to configure it. In this case, we call it master, but you can have a prod, you can have release, you can call it main. You can have several types of branch protections, and we really encourage this because this will allow you to protect any changes that are happening into that branch by validating and having somebody review it. Once you have these checks run, then that allows you to then merge the code into your production. So in this case, I'm requiring a pull request review before merging. So I'm only requiring 1 reviewer. Most of the times you probably want to have a code owner that's more knowledgeable of the code changes that are happening. And we're also requiring a couple status checks. So in this case, we're running the build job, so that's also required. And then we also have our 3 test jobs running against the 3 different Kubernetes versions. The reason why this is important is because again, we are compatible. Our application is supposed to be compatible against all of these. And if it's not compatible against one of these, then it will be an issue. So we do not want to merge that code into production. You can configure to allow different other types of requirements. You can have required commits, and I know that's something that some open source communities are doing today, require linear history, and this can include administrators. So now that I've given a quick overview of the branch protections and the kind YAML, let's go back into our pull request and see what's happening here. Sweet. So we just ran a couple of our components. We see our setup kind job spun up. We have our start open storage job, start open storage step also running, and now we're running our environment checks. So Grant, do you want to talk a little bit about the different checks that we're running through?
Yeah. So basically what we're doing now here is we started OpenStorage. We started in the kube system space after spinning up the Kubernetes cluster. And this is running Kubernetes 1.16. Next, what we're doing actually is we're checking to see that the environment is set up. This is important because you can't run the test until you've ensured that basically the environment is set up, or else it basically won't ever run. So what actually is happening live now, as you can see, is that the containers are spinning up. So OpenStorage is 0 out of 2, 0 out of 3. Looks like OpenStorage just started 2 out of 2. And now we're running the tests because everything is successfully up and checked to make sure. And now we've created the token secret. We've created the storage class, and we've created a PVC. Now we're basically, test passed, luckily, and then live demos are always nervous, but yeah, test passed, it's all good, and yeah, so everything looks good. So what we did is we introduced that fix, and it fixed everything, and now the test is passing. And as you can see, if you go back to the PR and refresh, you can see that all of the tests have passed. We just need to get someone to review this pull request before we can merge it, but that's for another day.
In this case, I'll just do a quick review since I am the reviewer, so we can merge the code and you can see the change happening. So awesome. It looks good. I'm going to approve this.
Thanks, Sarah.
Great job, Grant. I love the fixes that you made. And now that we have all of our checks have been, all the changes have been approved by the reviewer, all the checks have passed, everything that is required, it has a little check mark next to it. Now we can completely merge the code. So let's jump back to our slides. So let's talk about our takeaways here. So what did we learn today? No more manual work. You can decide on the events that you want to trigger your automated workflows with. Decide on what type of events make sense for your suit the job that you need to run. So in this case, I have two examples. Should I run this test on every push to main, or should I run it on a specific push to main? In this case, I decided to only run it against our branch, our main branch, and only on our pull request to our main branch as well. When should I deploy to my app to GKE? Well, I don't want to deploy it every time somebody makes a push. I don't want to deploy it every time somebody creates a pull request. In this case, I only want to deploy it when I create a release. And that's how you can show it. And this is this is very similar to what you could do with other automation tools as well. You can use this in pipelines, in Jenkins pipelines, or Travis CI. So next up, after we decided what our trigger was, let's talk about our workflow. Our workflow here these are two examples of our workflow. I need to build my Docker image and push a DTR. That's one workflow. And then the other workflow was our kind workflow. I want to set up kind, spin up, and run my test against that. And I need Docker builds to be successful beforehand, just to make sure that all the images that we're pulling are the latest code. We also decided to set up branch protections. In these branch protections, we decided, we need a code reviewer, we need to have status checks, and we also disabled force push. We do not want anybody to erase any commits accidentally when they do a force push into our master branch. So let's do a quick recap. Our dev introduced some new code and created a PR. So that was an event trigger using the pull request events. Then we kicked off our first build job, following up with our KIND and cluster creation job. And with that second job, we actually had a matrix build that had 3 parallel jobs to test against all Kubernetes versions. And finally, we had branch protection rules already set where you can only merge your branch, branch changes into your master branch when the tests have passed. And thanks to Grant being such a great coder, all the tests passed, and we're able to successfully merge that code. So lessons learned. What were the lessons learned? Break down the build job and the KIND jobs into 2 separate ones. That made it much easier to have a cleaner workflow and to have different configurations for each of those jobs. Triggering end-to-end testing on only PRs to the master branch. You don't need to have end-to-end testing on every single push unless that push is the master. Use matrix builds to run your tests to validate against multiple Kubernetes versions. Well, in this case, we had our application running against 3 different Kubernetes versions to make sure it's compatible across all 3. And lastly, test against the same image in all your workflows. If you are building a brand new image during your workflow, then you should use that exact same image. You shouldn't have to build it every single time. You don't need to use a pre-existing one. So why did we do this? Overall, simplified builds, cleaner workflows, and more efficient runs. The end-to-end testing will otherwise be inefficient if you have them running per push, using up unnecessary resources. Having the concurrent testing with the same automation script made your life as a developer a little easier because you don't have to write another automation script, and it spun up everything based on our existing configuration. And at the end of the day, you always want to save time and resources. You don't want to reinvent the wheel. You don't want to talk about creating something from scratch when somebody else has already done that job for you. And if it's open source, you can just use the open source projects and leverage them for your use case. You can contribute back when you find a bug. You can contribute back if you want to enhance that open source project. At the end of the day, it's up to you as a developer to decide, what's the best solution that I need to achieve. And how can I do that in an automated way? In addition, you can use a Docker registry, Quay, packages, or whatever you want to manage your Docker images with, and pull from that image because you want it to always be auditable, and you can refer back to it if a change did happen and there was a breaking configuration change. You can always refer back to it and analyze that and use that image in your following tests. So with that, I'll pass it off. Oh.
Yeah, so
we're here. We're done.
Yeah. Thanks, everyone, for listening. Let us know if you have any questions, and we'll go ahead and answer them. Thanks, everyone.
Okay, so yeah, we're just going to go through some of the questions that we have in the platform. So let's see the first one, how you wrote the test to create storage class. I actually answered this, and you can actually check the actual GitHub code itself. So just github.com/skhalife/OpenStorage, and all the code is in the demo folder there. You can see the link in the Q&A section.
Awesome. So I'll be answering Alexander's question. Do you suggest to launch this per the CI/CD pipeline on each commit, or only on PR or a specific branch? In this case, we are only running it on PR to our master branch. We're not running it on each commit. Since it's end-to-end testing, we figured it's not necessary because it will use up too many resources.
Cool. So another question, we've been getting a lot of questions about the slides, and we will be uploading them after this talk. We'll upload them on Sched itself. So if you go back to where you saw this talk in the schedule, you can find the slides there.
Awesome. So we have one more question. Can we integrate the solutions with the rest of the CI tools like Jenkins? Yes, you can integrate the solution with any type of CI tool. If you want to write your own pipelines in Jenkins using Jenkins files, that's also a possibility. You can integrate that testing tools that Grant mentioned during our session in any type of CI tool that you want to today.
Yep. So we have a couple more questions coming in. So the question is, so this E2E testing is only for infrastructure, or is it also for application E2E testing? The answer is it can be both if you would like. If your integration test may involve application logic, then yeah, you could totally test both with this method. This method basically just shows you how you could spin up a cluster and run any set of tests. It's up to you what you want to test with this. If the test fails, don't you need to delete the pushed image from the registry? Do you want to answer that question, Sarah?
Yeah, you can delete it. You don't have to. You can just put a new image with a new version number that is based on the commit or hash code that you're using or shardcode that you're using. In this case, deleting it will save you some resources. So yes, you can clean it up afterwards. If you want to refer back to it and understand why it failed, you can always keep that image there and pull it locally, so then you can run your own tests locally. You don't have to run it on your CI pipeline.
Yeah. The next one is, can this pattern be used to test and validate Kubernetes YAMLs? Yes, definitely. That's probably the most useful. One of the most useful use cases is actually interacting with Kubernetes through these tests, because you can't really do that easily through unit tests. It's just not natural to do it that way. So yeah, you could totally do this, use this pattern to test and validate Kubernetes YAMLs. What you would want to do is just in your test scripts, whatever testing framework you're using, you could just apply the YAMLs and basically validate that the expected behavior is happening. Yeah.
Awesome. So I'll be answering Herman's question. So are there any plans for GitHub Actions to be multi-repo? Yes, they're open source, so you can actually use them across any type of repos. You can use them within your org. You can have an org template that allows you to create actions at the org level. So yes, the answer is yes to all of your questions. They can be used across multiple repos and they can be shared. So then you don't have to reinvent the wheel, rewriting an action every single time.
Yep. So another quick question. Can I get the GitHub link of the demo, please? Yeah, I'll answer with the link there in a second, but it's basically, yeah, it's also in one of the other answers, but I'll send you the link in a second. Question on KINDs. Are we using self-hosted GHA running on Kubernetes pods? Will I be able to create the KINDs in pod? Question on KIND. Are we using the self-hosted GHA? Not sure what the question is asking. Do you know? GHA?
Yeah, I'm not sure what GHA is, but we only have a couple of seconds left. So I think we need to take this offline back to the Slack channel. So if you have any other questions, we didn't get to all of these, please feel free to message us on Slack and we'll answer them there. Do you remember the GitHub link really quick before we close our session?
Yeah.
It's github.com.
Yeah, it's github.com/skhalife. It's SKHALIFE/OpenStorage, one word. And inside of there, you'll see a demo folder. And I'll send that in the answer for the Q&A there as well. Cool. So yeah, it looks like there's a couple more questions, but unfortunately, we're going to have to end here. Again, both of us are available on the CNCF Slack, so let us know if you have any questions there. Do you want to, what's your handle on the CNCF Slack?
It's Khalife.
Yeah, and mine's G Griffiths. So first letter, my first name, and the last name. You can find both of those in the talk details. So yeah, thanks everyone, and have a good KubeCon.
Thanks for attending a session.